All right, good day, class. This is Mr. Morales, and I'm going to be working out of Chapter 2, Lesson 8. Now, the chapter officially begins, the section begins on page 187. And you're going to see here that the title of this section is Constant Rate of Change. We're going to go ahead and do this first page together as a class with your teacher, whether it be me or Mr. Andrade. So I'm going to go ahead, for the sake of this video, and jump right into the examples on page 188. Now, on page 188, we have the title is basically just using a table. And it tells us right here, we're going to use a table to determine a constant rate of change. So right there, that's one of our new vocabulary words, constant rate of change. But although the phrase itself might be new, you're going to find out that it's basically another name for one of our old friends that we've already learned about. And let's go ahead and just jump right into this first example. So it reads, the table shows the amount of money a booster club makes washing cars for a fundraiser. If you don't know what a booster club is, that's basically one of those organizations that almost anybody has or can be a part of that raises money for different causes. Now, to continue the problem, it says, use the information to find the constant rate of change in dollars per car. So first thing we have to ask ourselves is, what do we need to determine? And according to the problem, we need to determine the constant rate of change in dollars per car. Now, right here, the word per. We have all heard the word per before, and we know it means out of one. And that's because we've used this phrase before when we talked about a unit rate. And basically, constant rate of change is a unit rate. It's another name. Depending on what you're measuring and what you're talking about, they can be used interchangeably. Unit rate or constant rate of change. It all just depends on how you want to reference it, but they really mean the same thing. They're kind of like two different sides of the same exact coin. So we want to know then, if we make this much money for this many cars, then how much money are we going to make for one car? That's the unit rate. Now, a lot of students have already been noticing that when we've been analyzing these tables here, like the ones we have here, that there's a lot of patterns happening. And if we look in this table we have here, we have a vertical table, we have numbers on the left and money on the right. The whole topic is about cars washed, which means this is the number of cars washed and how much money we make for washing the cars. And if we keep delving into what this table is telling us, we see that after 5, 10, 15, and 20 cars, we're making $40, $80, $120, and $160 respectively. And look how the table is changing. The number of cars, the way we're measuring it in this table is we're adding 5 each time. On the money end over here, we have that every time we add 5 cars, we are making an additional $40. Well, that information is helpful in helping us find unit rate. Now, here's a big warning I want to let you guys know. Although we have adding going on here, and you might even see subtraction on some tables, the adding and subtracting part still do not tell us what the proportion is. So don't rely on these, because remember, we made a big, huge point to let you guys know that when we're dealing with proportions, it's always multiplying or dividing. And you're going to see that there still is multiplying and dividing happening in the table. There just happens to be some additional stuff happening on the sides. But what if I was counting by, let's say, 3s or 4s or 7s, or even counting one car at a time? Then these numbers, these rates of change over here on the side would be different. So here's another idea I want to make with you. This is just a rate of change. This is just how the table itself is changing. That doesn't mean that we're necessarily getting 5 cars in every single time. It just tells us that this table is measuring these two things a certain way. And that certain way is pretty obvious in this case. For example, the money is increasing by 40 every time. So the rate of change in money is it's changing by 40 for every measurement. The measurements that are changing the same way too. The measurements, which is the number of cars, is changing by 5 each and every time. So these are rates of change, but they're not the answer to the question, which is, what is the constant rate of change in dollars per car? So let's not get too confused. We have to know exactly what is being asked. Now, we've already learned how to find a unit rate. All it is you take some data from the information we're given. So I can pick any set of points here, any number of cars and the money made. And I'm going to go ahead and just take the first one right here. I know that I make $40 if I wash 5 cars. Well, then the question becomes to find the unit rate, how much money do you make for 1 car? So you simply divide 40 divided by 5. And as long as you know your times tables fairly well, you know that 8 times 5 fits into 40 perfectly. So therefore, we know that we get $8 for every 1 car that we wash. And that's exactly what this example tells us. $8 for every car. It's also very important that, yes, most of you guys I've seen can find these numbers, but you have to know exactly what they're describing. Because what if I was to pose a question and tell you that maybe it means for every 8 cars we make $1? And if you're not paying attention, you might fall for that trap and accept that as an answer. So it's very important you know exactly what's being measured at all times. Now here we have a little side note which kind of reinforces what we discussed, and it says the unit rate. A rate of change is usually expressed as a unit rate. That means they're the same exact thing. A unit rate is the rate of change. Very easy. Now, I want you to take what we just practiced and go ahead and try the got it A and B. Reference the above example in order to help you down here. Now, not only do they want to know what the rate of change is for both examples, they want you to explain what it means. Now, up here in got it A, there's something you have to pay attention to, and that is they want to know the approximate constant rate of change. The word approximate probably means you're going to have decimals involved. And if that's the case, I would suggest you round to the hundredths place, which means you round to 2 spaces after the decimal point. All right, so good luck. And if you have any questions about these 2 got it's, make sure you come in the morning or after school before the notes are due to get help. Let's go ahead and continue now to the next page. On page 189, we're going to take a different approach now, and we're going to go ahead and analyze a graph. So the previous page talked about looking at just a table. Now we're going to use a graph, and this is very high school algebra kind of thing. So you guys should be pretty proud of yourself that you guys are doing what used to be considered high school level work. Now, for using a graph, the objective is pretty straightforward. We can use a graph to determine a constant rate of change, there's that phrase again, and to analyze points on the graph. Graphs are a lot more interesting to read, and they probably tell us more information, at least for students, than just reading a word problem does. And believe me, I've worked with students long enough to know that most of you guys would rather look at a picture than read a story. But nonetheless, we're going to look to see how both of them work together. So in example 2, it says, the graph represents the distance traveled while driving on a highway. Determine the constant rate of change. So we're being asked to find the rate of change. And our previous note told us the rate of change is expressed as a unit rate. So we're going to have something out of 1, something per something. Well, what are we measuring? Let's look at this graph. We know that we're measuring time and distance. So we pretty much probably want to figure out how far we're going in miles per hour. So we know we're going to have miles up here. We want to know how far we go in miles in 1 hour. Now this graph has several points that are indicated to us. Let's go ahead and analyze them. The first point is down here at 0, 0. That's the origin. We know that that point is necessary for anything to be proportional. And since we're talking about proportional relationships, we know this line has to go through the origin. Now, another feature of this line is that it's perfectly straight. If you follow it from the beginning all the way to this tip of the tail over here, it's a perfectly straight line. That is a very special property known as being linear. This word is extremely important for you guys to learn. Basically, it has the word line in it. That's because any graph that makes a straight line is called linear. So instead of saying straight, let's try exchanging the word out for linear. It's more mathematic, and you're going to be using it a lot in the upcoming lessons. So a proportional graph must go through the origin and be linear. On this line, we have some points that are designated for us. We have the point 1 and 60, 2 and 120, and 3 and 180. These points represent not only positions on this line, but they also tell us that at different times how far we've gone. For example, at the origin at 0, 0, we know that when no time has passed or 0 hours have passed, then we have a distance of 0 miles. That makes sense. If the car is not moving for any amount of time, then we're not going anywhere at all. The next point here is at 160. The number 1 represents where we are on the x-axis down here. The number 60 represents where we are on the y-axis over here. Where they intersect is our point. 160 means that when the time was 1 hour, we have gone a distance of 60 miles. We can apply that same thinking to our next point up here, which is at 120. The 2 represents the number of hours that have passed while we were driving on the highway, and the 120 represents how far we've gone in those 2 hours. So in 2 hours, we drove 120 miles. And continuing at the same exact speed, we know that at 3 hours, we traveled a total of 180 miles. So these data points give us a location on the graph to make our line and tell us how we're moving. Once we know how we're moving, we could very easily find out how fast we're going. The best way to do it is to take your first point and your last point. So let's go ahead and look at our last point. It is at 180. That means that in 3 hours, we went 180 miles. Now, I'm going to go ahead and find the unit rate using that. I'm going to divide 180 by 3, and I get 60 over 1. But I have to know, what does 60 over 1 mean? And I have two things. One has to do with time, and one has to do with miles. Either I can say, in 60 hours, I traveled 1 mile, or I've traveled 60 miles in 1 hour. Using some common sense, which one sounds more logical? Do you think it would take you a couple of days to travel 1 mile? Or does it sound more correct to say that you've gone about 60 miles in 1 hour? And hopefully you guys have all realized that the miles per hour, which is how we refer to time and travel when we're moving in a vehicle, is the logical and correct choice. And that's what we see down here. Now in the example in the book, they used the first point, 60 and 1. And that's fine. That's an easier number to use. 60 divided by 1. Well, once you have 60 and you have your 1, you automatically have your unit rate. So there's a big clue right there. If you have a graph and you know where the 1 is and you have a number that goes with it, then you don't even have to do any math. You're already given your unit rate. So use the graph to your advantage. Save the whole process of dividing if you don't want to, and look for the unit rate automatically. Now, there's still a little more about this graph that we need to talk about, and that takes us to example 3. It says, explain what the points 0, 0, and 160 represent. So not only is it enough to recognize that a graph is proportional, we have to know, just like I said before, what all the points mean. We know the origin 0, 0 means that when no time has passed, no miles have been gained. We haven't traveled anywhere. The point 160, we use the same exact method. We know that number 1 represents the time in hours. So when 1 hour is passed, we've gone 60 miles. Our distance is 60 miles. You have to know how to write that and explain it, because you might be asked to when you're tested. So go ahead and attempt now. Got it, C and D. They are exactly like example 2 and 3 and above. Reference those examples. If you're still having questions or you're not too sure, come and see your teachers before or after school, but do it before the notes are due if possible. All right, and finally, we're going to move on to our final example on page 190. So turn your page over, and let's go ahead and look at example 4. Here, we have both a table and a graph mixed together, or shown side by side. And it says, the table and the graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? And they want us to explain. So here's a really nice example where we have 2 ways to see data, and we're talking about 2 different places. We have Pedals Rentals, which rents bikes. That's the name of the store. And then we have Super Cycles. We want to know who charges more per bike, which is who has the more expensive prices. So Pedals tells us in their, let's say on a sign, that to rent a bike for 2 hours, you pay $24, 3 hours is $36, and 4 is $48. So first we want to look to see what kind of patterns we notice. We know the rate of change on this chart for the time is, for every hour increase, we get an increase of $12. So I suspect that we're going to have a constant rate of change. But let's go ahead and figure out what it is. I'm going to take how much we pay, which is $24, for the amount of time they were allotted, which is 2 hours, and then figure out the unit rate, which is the amount of money I would pay for 1 hour. Well, this is pretty easy math. $24 in 2 hours means I'm paying $12 an hour. I need to verify that this rate of change is truly the same for all my examples. So I know it works for 2 hours. Does $12 times 3 give me 36? Yes, it does. Does $12 an hour times 4 give me 48? Yes. So at Pedals Rentals, I am charged $12 for 1 hour. That is their rate. Let's look at Super Cycles now. Instead of giving me a sign with all the amounts, they gave me a graph. So I'm going to look for some really easy points. And the best one to always look for is 1. So I go up on my graph, and I have a 1 right here. And when I come right across to the y-axis, I have an 8 right there. So I have to figure out what I'm looking at. I know I have a 1, so there's my unit rate. I have an 8. What are these things that are measuring? Well, the 1 represents the number of hours. And if you look at this, because the 1 and the hours are on the bottom of the graph, that's my denominator, or the bottom of my ratio. The cost is the side that goes up, so that'll be the top. 8 is measured in dollars. So over here at Super Cycles, I only have to pay $8 an hour. I didn't bother to check any other points because I can see that this line is linear and it goes through the origin. So I already know that all the rest of the points are going to be proportional to this exact unit rate. So Super Cycles charges $8 an hour. Pedals Rentals charges $12 an hour. The question is, who charges more per bicycle? That would be Pedals Rentals. It says to explain. When I compared the unit rates, I see that Pedals Rentals, which is $12, that's $4 more an hour than Super Cycles. That's way more expensive. You have to be able to explain all those things from graphs. That is the goal for this assignment. If you can't reach that level, we're going to need to really work on this a lot more, because most of the STAR tests can be solved using this kind of thinking, believe it or not. Now, you guys need to go ahead and work on the guided practice numbers 1 and 2. Remember that the odds are in the back of the book, so you need to go ahead and work on 1 and 2 on your own first, and then compare what the answers you get to what's in the back of the book and see how close, either far off or right on you were. If there was an issue, feel free to go ahead and ask a teacher for some help, and we can get clarification. Good luck, guys.